everyone, it's Tony with Hidden Light Photography, and we're on our second to last episode of our flat field correction series. And today we're going to be taking everything that we've learned so far and learning how to fine tune our flat frames in order to correct for undercorrection or overcorrection. So if you haven't done so yet, hit that subscribe button. I don't want you to miss out on any valuable information. Now let's jump on in and learn how to fine tune our flat frames. Before we get started, it's important to understand that for this exercise, you're going to want to use your master flat dark and your master dark. Don't use individual dark files to do this. When it comes to your flat frame, I do not recommend using the master flat because that would already be calibrated by a flat dark from a previous session. So for the flat frame, use an individual flat frame as this will give you the best results. In part 2, we left off with an image that was overcorrected, such as what we see here. And then in part 3, we went over a quick and easy way to find the linear range of your camera. Now it's important to understand that the method that I showed you to find the linear range of your camera is not by any means a scientific way of doing it. It's just a quick and easy way to have a visualization, as this subject can be very much so overthought and it doesn't need to be. Ultimately, when you're imaging your flat frames and you're looking at the histogram to find the ADU value that you're sitting at, you'll have a minimum value on the histogram and a maximum value. You just want to make sure that the maximum value of the histogram has no pixels at the maximum capability of the camera, and the minimum value on the histogram has no pixels at a 0 value. And if you have any dust motes, you want to make sure that they're showing up on screen. As long as you meet that criteria, your flat frames will be just fine. So why do images overcorrect like you see here or undercorrect? And that's what we're going to be going into today, as well as how to solve it. So here we have the red channel, and we have an overcorrected image. I'm going to go ahead and name this red overcorrect. And I'm just going to place this off to the side. What happens in pre-processing, such as WBPP? What does our image go through? So let's go ahead and run through this really quick. And if you remember from the general orders of flat frames, if your flat frames are calibrated with flat darks, exposure time must match that of the flat frames. All involved frames must have the same camera settings: temperature, exposure, gain, offset. And when I say same exposure, your flat darks exposure time must match that of your flat frames, just like your dark frame exposure time must match that of your light frames. The flat frame ADU must be within the sensor's linear range, which we just went over. That there's nothing that needs to be overthought with that. Just meet those 3 criteria. And flat frames must be taken with the same filter or filters that the light frames they are meant to calibrate were taken with. Flat frame rotational orientation must match the light frames. The light source must provide even illumination. And then if there were dust motes, they must match between the light frames and the flat frames. In other words, at the rotational orientation, everything must match up. And then the vignetting pattern of flat frames must match that of the light frame. Also, rotational orientation can come into play with this. Now, as far as flat field calibration, I like to think of it as light waves. To cancel out, they must be at the correct state. In other words, if your flat frame has a bright area and is trying to calibrate a bright area of your light frame, it's not going to work. Just like if your flat frame has a dark area that's trying to calibrate a dark area on your light frame, it's not going to work. They need to be opposite. And they also need to match. Otherwise, you're going to get some weird phenomena. So what exactly does WBPP do to pre-process your images, or any pre-processing software at that? We're going to go through a very basic layout here. We'll start with our light frame, and we're going to calibrate the light frame. Then we're going to calibrate our flat frame. And then we're going to go ahead and finalize with a master light. So what we're going to do here is first, let's make sure that our dark and flat dark match. In statistics, which can be found in process all processes, and then you'll see statistics, let's go ahead and take a look at our flat dark. We have a mean value of 502.346. And then our dark has a mean value of 502.877. So we can safely say that our flat dark and our dark match each other. So let's go ahead and let's go into pixel math. Also can be found in process all processes, and then we have pixel math. What we're going to do is, and again, this is a very just basic visualization of what happens behind the scenes, light minus dark. We're going to go ahead and create a new image, and we're going to call this light cal for a calibrated light frame. Triangle, drag and drop. And let's give it a stretch. Let's minimize our light frame. Let's minimize our calibrated light frame. Now let's go ahead and calibrate our flat frame. Flat minus flat dark. Let's bring up our flat frame. And let's call this one flat cal. Again, creating a new image. Triangle, drag and drop. Let's minimize our flat frame, and let's go ahead and minimize our flat calibrated frame, or our calibrated flat frame. Now, what we need to do is take our calibrated light frame, light cal, and then correct the flat field here. And to do that, what we're going to do is go light cal times median times flat cal divided by flat cal. And what we're going to do is use the calibrated flat frame, flat cal, to flat field correct our calibrated light frame. Let's call this one master light. Triangle, drag and drop. Let's minimize our calibrated light frame and give a stretch. And there we go. Let's put them side by side. Let's get rid of pixel math for a moment. We can scoot statistics out of the way enough. And we can see the difference. So what are some things to look at if you find yourself in a position where you're overcorrected like you see here? One cause could be that your dark frames were not used to calibrate your light frames. Let's take a look at what happens. So let's take our master light, let's put it up to the top. Let's take our light frame here, which has not been calibrated. Let's go ahead and bring out pixel math again. And what we're going to do is we have our light frame that we started with. We're not going to calibrate it with a dark frame. Instead, we're just going to use our calibrated flat frame right over here, flat cal, to flat field correct our uncalibrated light frame. So instead of light cal, we're going to just do light. Light times median of flat cal divided by flat cal. And let's name this, let's just say light 2, just to make it easy. Triangle, drag and drop. Give it a stretch. And we have an overcorrection scenario again. So one thing to check is to make sure that whichever software that you're using is actually taking your dark frames and calibrating your light frames with it. Now there's another reason that you could overcorrect. Let's go ahead, we don't need light 2 anymore. Let's have a little bit of fun with this one. Let's go and take dark times 0.5. And let's call this darker. Triangle, drag and drop. And let's put that off to the side for a moment. Let's calibrate our light frame with this. We're going to go light minus darker. Let's call this light cal. Okay. Let's move light cal off to the side. And now let's go flat dark times 1.5. And let's call this flat darker. And we'll move this off to the side. Can anyone guess where I'm going with this? Let's take our flat frame and now let's calibrate our flat frame with our flat darker frame. Flat minus flat darker. Let's call this flat cal. Triangle, drag and drop. And last but not least, let's go light cal times median, open parentheses, flat cal, close parentheses, divided by flat cal. Let's call this master light 2. And triangle, drag and drop. And we have overcorrection. So what happened? Let's go into statistics. And if you heard me just a moment ago, does anyone know where I went with this? Our original dark had a mean value of 502.877. Our darker frame now has a mean value of 251.441. Our original flat dark frame had a mean value of 502.346. And our flat darker, it has a mean value of 753.519. In other words, our dark calibration frames do not match each other. So why does that make an effect? Well, here's what happens. Our original light frame has a mean value of 1,236.5. Our calibrated light frame, light cal, even though it looks similar, if we go to light cal, has a mean value of 985.6. So when you calibrate your light frame with a dark frame, it's changing the mean value. The same thing goes for your flat frame. Our original flat frame has a mean value of 24,747.9. And our flat cal has a mean value of 23,494.4. So as you calibrate your frames, your light frames and your flat frames with darks and flat darks, it's changing the mean value of those frames, of those channels. So they aren't calibrating correctly, and that is exactly why your dark frames need to match each other as far as mean value. It's also exactly why your temperature needs to be the same, your all of your camera settings, gain, offset, all of those affect how the mean ADU value is presented within that image. And any discrepancy, any difference will affect and give you strange results. So if you find yourself with an overcorrection scenario, check your dark frames. 9 out of 10 times, it's going to be an issue or a discrepancy with your dark frames as far as the mean value goes. And what you're going to want to check, if you have a wide discrepancy, you're not going to have one that's, a swing like 251.441 to 502.877. That's just very exaggerated. But even small differences can make an effect. You're going to want to check. For example, I'll give you a personal example here. I will image my dark frames from my light frames inside the house on a rainy day, cloudy day, whatever it might be. And I'll use, or used to use, Nina's Flat Wizard to image my flat frames and then immediately image my flat darks. I had a difference. There's a difference there. And it's because the camera is not in the same spot that it was in to take the dark frames, right? Don't forget, I have that bright street light that shines right down on the telescope, and it was throwing my flat darks off. It was giving me a different value, only a few ADU difference, but it was enough. It was enough to give me a weird flat field correction. So if you find yourself with a discrepancy like that, redo your dark frames. Redo them, get them to match, and then reapply, right? Pre-process in WBPP or whichever software you have, and see if that fixes your results. Everything must match, right? Now, the other thing that you can do, if you have a very small discrepancy here, like let's just take our dark frame here, 502.877, and then our flat dark, that's 502.346. What we can end up doing is bringing up the calculator, and we'll do 502.877 divided by, we'll take our flat dark, 502.346, and then we can actually use pixel math here. Let's bring us up some room here. Let's grab our flat dark, and we can go flat dark times 1.00105. We don't have to put all these decimals in, but 1.00105. We'll create a new image, and then we'll call this new flat dark. And then we can go ahead and fine-tune match our images. So now new flat dark is 502.873 compared to our dark of 502.877. So if you have a discrepancy of a couple of ADU, there's really no reason to reshoot your dark frames. You can just pixel math them to match. But if you have a wide discrepancy, I would reshoot them. Keep in mind too, when you're using a cooled camera, your sensor does change over time. You can really only hang on to a dark library for maybe 6 months, and then you're going to have to redo your dark frames just because, you know, sensor degradation and different changes that happen within it. So if you're using dark frames from a year ago, or I would say really anything north of 6 months ago, and then you're trying to use them to calibrate your lights, but you have a fresh set of flat darks, chances are you're going to have a discrepancy in the mean ADU value. So you're going to want to reshoot your darks every 6 months. Now, let's go ahead, let's get rid of new flat dark, and let's take a peek at Master Light 2. If it's just not an option to reshoot darks, you can actually, if we take our flat cal here, overcorrection like you see here means that your flat frame needs to go brighter. If you have undercorrection, which is the exact opposite of this, think of overcorrection as reverse vignetting. If you still have heavy vignetting, that's undercorrection. That means that your flat frame needs to go darker. So overcorrection needs brighter flat, undercorrection needs dimmer flat. Let's take our flat cal here, and let's do flat cal. Let's add a value to it. Let's say plus 0.1. And let's say new flat. Triangle, drag and drop. Let's minimize flat cal. So now we have new flat. We added some value to our calibrated flat frame here. You can visually see that it's brighter, but also in statistics, flat cal 23,494.4, new flat 30,047.9. Now, let's go ahead, let's pixel math this in. So we have our overcorrected image, master light 2, and we want to see if we can get rid of the overcorrection that we see by increasing the value of our flat frame. So what we're going to do, let's minimize master light 2 and let's bring up light cal. Again, light cal has been calibrated with our dark frame, and then we increase the value of our flat frame, calling it new flat. So what we're going to do here is light cal times median, open parentheses, new flat, close parentheses, divided by new flat. So now we're going to be flat field correcting our calibrated light frame with our updated flat frame. Let's call this master 3. And we're going to go ahead and triangle, drag and drop. And give it a stretch, and there we go. Just by increasing the value of your flat frame. Now, keep in mind, this is going to be like a car with a dead battery. You can use a jump pack to get it started. Ultimately, you're going to want to correct the issue at hand. So whatever might be causing you to overcorrect, such as mismatching dark frames, you're going to want to make sure to correct that, as increasing your flat frame value. As you can see, it'll do the job, but it's kind of a band-aid. Let's go ahead and exit out, and let's go ahead and exit out of new flat. Let's see the opposite end. Now, again, overcorrection, you need a brighter flat frame, and undercorrection, you need a dimmer flat frame. So we added 0.1 to flat cal. Let's go ahead and do flat cal plus 0.4. And let's call this bright flat. So you can see we're really bright on this. In fact, flat cal, again, had 23,494.4, and bright flat is 49,708.4. So let's go ahead. We have light cal here already up and ready to go. Let's go light cal times median, open parentheses, bright flat divided by bright flat. And let's call this, let's just call it underlight. Triangle, drag and drop. And here we have a little bit of undercorrection. In fact, if we had this to compare, if we take a look at the bottom corners, we are darker on our underlight than we are on our regular master light. So we have a little bit of undercorrection. So keep in mind that if you have an undercorrection scenario like you see here, you will need a dimmer flat. Whereas if you have an overcorrection scenario like you see here, you're going to need a brighter flat. And ultimately, there is an underlying cause. Unfortunately, it's not a straightforward answer. It does require investigative work through your files and numbers and making sure that things match and finding the thing that does not. You could even have a mechanical issue with the telescope, such as a light leak. that would end up causing things to not match, such as my scenario with shooting darks inside versus shooting my flat darks outside, and the street light was causing a light leak, thus making my dark frames not match. Um, so, like I mentioned in part one, it can be a very tedious, overwhelming task. Um, it just takes some time and patience. Fortunately, though, as we saw, we can adjust our flat frames to fit our needs to help us get in the right direction and at least help save some of the data. And in part five, we're going to be going over what to do if we have issues with the light frames themselves, because sometimes that can be extremely scary, especially if we spent hours on a target and now it's out of view until next year, and we have some issues that just seem hopeless. Finally, to implement the changes that you like, it could get a little bit confusing, but what you're going to want to do is, as you find the changes to whichever files that you want to change, we'll take this dark frame for example. If we found a value that we like and gives us a good result, what you want to do is, instead of creating a new image, you'll actually run the change and replace the target image. In other words, let's go ahead and name this dark, and we'll go dark times 1.2. We'll replace the target image. And what this does is it'll actually retain the fits header information, so WBPP will still recognize this as a master dark. From here, we'll go to File, Save As, and then we can add a little extension such as underscore brightened, and then we can go ahead and save it. And then instead of loading all of our individual dark files into WBPP, we can actually just go ahead and load our adjusted master dark. And the same goes for the flat dark. You'll go ahead and replace the target image, put in the change that you liked, save it, and then we'll load the newly adjusted master flat dark into WBPP instead of the original flat darks. And by replacing the target image, WBPP still recognizes this as a master flat dark. Now, if you went ahead and made a change to your flat frame, nothing done to the darks, the only change was done to the flat, what you would do is take your master flat frame that was generated through WBPP and make the adjustment to your flat. So in other words, let's name this flat, and let's say the change that we liked was flat plus 0.2. We would replace the target image, and then we would go ahead and go to File, Save As, and then we have, we'll do something like underscore brightened, just like you saw, or +2, whatever it is that will allow you to identify it, save, and then we can load the newly adjusted master flat into WBPP instead of the original flat frames, and then let WBPP do its thing. If you made changes to both, this is where it gets a little bit more confusing. Do your master darks first, run WBPP, and then take the newly generated master flat, make the adjustment to the master flat, save it, and then load the new master flat into WBPP and run it again. Now, I'm not saying that that's the correct way to do it, it's just the way that I do it. And the reason is, if you made changes to both, keep in mind, whatever change you made to your flat dark affects the flat. So if you made your change to the flat dark and then you had to fine tune the flat in order to get the final result that you're looking for, You're going to want to have WBPP calibrate your flat frames with the adjusted master flat dark, and then go in, make the final adjustment to the flat, and then run again to get the final calibrated image. And if you need any help with this, please feel free to ask. I know this part can get really confusing. And if you want me to make a video actually demonstrating this, drop a comment in the comment section. I'm more than happy to do so. Again, I know this part can get a little bit confusing, and I'm trying to word it as best as I possibly can. So I hope you found this useful, and if you did and want to help support the channel, check out that join button and consider becoming a Hidden Light Photography member. There's lots of perks in it for you, and your support helps me create more content to help bring the universe to your fingertips. Also, do me a favor. That channel icon that popped up, hit that channel icon and subscribe. I don't want you to miss out on any valuable information. Drop a comment in the comment section. What questions do you have? Are you having issues getting your flat field to correct? And then check out that next video. Until the next time, clear skies.